Hello all, welcome back to the Career with Vasanth YouTube channel. My name is Vasanth. I hope you all doing well. I'm back with another new DSA topic. Without wasting further time, let's get started. The topic is two-pointer approach. Okay. In that video also I mentioned you there are two different ways to look at the DSA problems. One is like you keep solving the various different data structure problems. Like for example, you solve array problem, linked list problem, trees problem, and goes on. The another way to look at the DSA is there are a few techniques in data structure algorithm problem solving. Like there are techniques like two pointer, sliding window, and multiple other techniques are there where you pick those techniques and solve problems from all the data structures within that. Okay, for example, you pick a sliding window and you solve sliding window related questions in arrays, strings, linked list, trees, etc. Okay. See, the second technique of solving problem is useful for those who already know very well about the data structure. Like you should know how to traverse a tree first. Without that, if you pick up problems just with the help of technique, it's not going to work. Okay. Now let's understand more about this technique by looking at a problem. Okay. So in a sorted array, find a pair exists with a given sum yes. So const array is 2, 6, 5, 8, 11. So this is an array. And we have n as 5, which is the length of the array, and target is 14. Give a pair of numbers. See, in a sorted array, this is very important. In a sorted array, find a pair that exists with a given sum. Like for example, 2 plus 6, will it make 14? No. 11 plus 2, will it make 14? No. 6 plus 5, will it make 14? No. 8 plus 6, will it make 14? Yes. So 8 and 6 will make the 14. So definitely similar questions you might have studied during your graduation. And the easiest solution to solve this problem is writing a function. Function pair exists, array n and s. So we use two for loops. The first for loop is where starting with the 0th index. Second for loop is where starts with the 0 plus 1 index. So where for 2, we add 6 and see will it produce us some 6. Then we see 2 plus 5, 2 plus 8, 2 plus 1, 2 plus 11, one iteration over. And then for 6, again, we are going to check 6 plus 5, 6 plus 8, 6 plus 11. So most of you who might have looked at this solution would know that complexity of this. That is the complexity of this approach is the n square. Because there's an outer for loop, there's an inner for loop that is n square. Correct? So just to say whether the particular pair exists or not, we need to process the array 2 times. Okay. Now, so this is one way of solving the problem, what we call a brute force way of solving. There is a better way of solving the problem as the array is sorted. Okay. So that particular technique that we are using is the two-pointer approach. Okay. So this is an example in sorted array, find a pair exists with a given sum is where we're going to determine how two-pointer approach is basically help us to save the time complexity. But before that, let's understand what is a two-pointer technique. Two-pointer technique allows us to keep two pointers referencing two different locations in a different data structures like array, linked list, etc. Okay. So basically, instead of having one pointer pointing to one particular location in the array or different data structures, we are using two pointers pointing to two distinct locations within the data structure. For simplicity purpose, let's assume array in two different locations so that the processing becomes much faster. By looking at the diagram only, by now you might have understood. As the array is sorted here, 2, 6, 5, 8, 11, correct? How about I keep one pointer here and one pointer here? And I keep adding like 11 plus 2. Is it producing the sum? No. Then I'll move the position to I position to here and probably the j position to here, and then I'll add. So in the second iteration itself, I got the value. So instead of n square, it become n. Let me show you regarding code as well. Okay. So what we are doing, if while I is less than j, so here I is pointing to the starting location. The j is pointing to the ending location. Okay. N minus 1 as you can see. While I less than j, current sum is array of I plus array of j. That is nothing but, let's say I copy this for paste here. So first it is 2 plus 11, which is 11 plus 2, which is 13. Okay. So we have a check. If it is sum, then we are going to return true. If it is lesser than sum, then we are incrementing I. That means sum is less. So then we are incrementing the ith indicator. From 2, we are going here. If sum is sum is more than the given sum, like for example, uh, array of I plus array of j, if it is greater than the current sum, then we have to reduce this pointer. The reason being, if I increase this pointer, as it is already sorted array, if I move further towards the right, then basically I'm going to increase the value, which is not expected. Correct? So whenever the value is increasing or whenever the sum of two numbers is greater than the target, then we are going to reduce this. Whenever it is lesser, then we are going to increment this. Okay? That's how it's going to work. As you can see, when the current sum is equal to sum, return true. When current sum is lesser than yes, then you are going to increment I plus plus. When current sum is greater than the S, then you're going to do the J minus minus. So whenever the value is higher, like whatever the sum is higher than the target sum, so reduce this. Whenever the target sum is lesser, then basically increment this so that you're going to produce get a higher sum. Okay. So as simple as that. It's not about primarily understanding the code here. It's about understanding the technique. Instead of like one pointer, you're having two pointers pointed to two different locations in the array. And you would be incrementing this pointer and you would be decrementing this pointer to get the given sum. So this is two pointer approach, how we can save the time complexity. Okay, from n square, this approach is just n. Let's look at another example of space complexity quickly. So given an array, reverse it. Very simple. So how you're going to reverse? So basically you are going to take the another array and you are going to iterate I is equal to 0, I less than n, I plus plus. So n minus I minus 1, this is one approach. Or you can iterate the array like I is equal to n minus 1, I greater than 0, I minus minus, and you're going to put the like reversed value into the reversed array. Like instead of like you take the same array, keep the ith index here and keep adding the values into the reversed array. Okay. The only problem here is you are having another space, like another array, correct? So space complexity of this algorithm is n. Like imagine a case where this array has 1 million items. So for reversing 1 million item, if you have to create another array of 1 million item, then you're going to taking a massive space. Okay. So which should be ideally avoided. Now we'll come here. Two pointer approach, what we are doing. You can also think actually. We have two pointers. One pointer I keep here. Another pointer I keep here. Swap the values of the two pointer. Decrement this, increment this. And again swap these two values. Whenever we hit the middle, stop it. As simple as that. Okay. So where same is done here. I is equal to 0, j is equal to n minus 1, I less than j, array of I, comma, array of j, comma, array of I. You no longer need to use the way of using a temp variable to swap the values. With the help of this sort of an expression, we can swap the elements at one go. Okay. I plus plus j minus minus. When I is less than j, I is less than j. So no matter whether it's an even array or odd array or even array or odd number of elements in the array, whenever the I crosses a j, it is assumed to be like we crossed all the elements. Okay. So instead of like using the n square, instead of using the n space, we just able to do within the one space. That is within the given array only we are able to reverse the array. Okay. So this is about the two pointer approach. So again, one last time if I have to iterate, instead of using one pointer or one direction of iteration, use whenever there is a possibility of using a distinct location to start and end, and we can start the processing. That's when we are going to use the two pointer approach. And especially keep in mind whenever there's an array sorted or where the string sort of an example where string is with a sorted, whenever the sorted comes, think of this kind of an approach. Or there are slightly advanced version of this called one. So that fast pointer and slow pointer also approach that we use in the linked list. I'm going to explain that in the upcoming videos. That's all for this video. If you like the video, please like. Whatever you felt honestly, please comment. Share the video with your friends so that they also get benefited. My intention is to bring as much more content as possible with in DSA for front-end developers for free. That's the whole intent. So I'm making more and more videos. If you want any specific videos, please do mention that in the comment section. My last two videos regarding a strategy and how to crack Google DSA has got quite good viewership. Please do watch the videos. So link to that in this that particular videos are in this playlist only. And I write very actively on LinkedIn about front-end interview preparation. Please do follow me. I have a Telegram group of 3,200 plus members where a community of developers sharing knowledge and sharing job related information. Please do join. Thank you so much for watching. Catch you in the next video.